In this lab, we're going to continue with the idea of how far something goes and how that measurement can either be a scalar, which is just a number, or a vector, which is a number that includes a direction. Okay, and we're going to kind of take that into the next step, which is how long it takes for it to get that far away. Okay, in other words, the rate of the motion can either be called speed or velocity. Speed is the scalar version of your rate of motion, and velocity is the vector version. Okay, so we're going to be looking at vertical distance again, how high this elastic popper goes and how far it falls, as well as horizontal displacement, how far out our reaction rocket goes from its dropping point, but also how long it takes for it to move that far. Okay, so by the time this popper launches, we will start a timer, and by the time it hits the ground, we'll stop it and see how long that takes. Okay, same thing goes for our reaction rocket. How long does it take for it to launch and then to hit the ground? All right, so we're going to be using this timer to keep track of how long it takes for something to travel like that. And again, for the elastic popper, we're going to be doing total distance, so up to down. So however high it goes, it's got to come that far down. We're measuring from that. To make it easier, so that I don't have to try and use 2 meter sticks at the same time. Whoops. From the ground to here is about 77 centimeters. So however high up the popper goes onto this meter stick, we're just adding 77 centimeters to that. Okay. In the previous shot, I had the meter stick upside down, so I've now flipped that back the right way, so we're counting upwards. So this is going to be 77 centimeters plus however high up on this meter stick our popper goes. I've got my timer, so I'm going to be timing this out as well. That was about 0.54 seconds. It's about 0.69 seconds. That's about 0.51 seconds. That one was about 0.57 seconds. About 0.66 seconds. Now we're going to do the same thing for our reaction rocket, except we'll be including the direction again. So again, this time I've got my direction towards the camera as being up on the paper. So when we have a direction along with the rate of motion, it's not just speed, it's called velocity. So I'm going to drop this. When it hits the ground, I'm going to start the timer. And when it hits the ground again, I'm going to stop the timer. So here we go. All right. So I'll measure the distance from here out to here as the horizontal displacement, and I'll be dividing it by the time it took to get there. Okay, like in this case, it took 1.05 seconds to get there. Okay, and I measure out this distance. Okay, with the direction, it becomes displacement, and then I'd find the rate of motion by taking that displacement divided by the change in time it took to get from here to here.